Imagine, out there in the vastness of space, there are certain unknown objects that are just zipping by. What could they be? Aliens, comets, or something we can't even fathom? And in between these quests, Voyager 1, the spacecraft launched by humans, has spotted 775 mysterious objects zooming through space. Yes, you heard it right. Neil deGrasse Tyson recently shared this mind-blowing discovery. Tyson's revelation adds a dash of cosmic mystery to our universe, inviting us to ponder the enigmatic wonders that lurk beyond our reach. Let's have a tour into the cosmic unknown and explore the secrets hidden in the depths of space. Voyager 1, the farthest traveled spacecraft from our home, has been on a cosmic exploration journey for more than 45 years. Despite its extensive travels, it continues to unveil new discoveries daily. Recently, Neil deGrasse Tyson confirmed a perplexing revelation made by the spacecraft. Voyager 1 identified the presence of 775 celestial objects during its exploration of interstellar space. This finding has become a captivating mystery for the scientific community. The question arises, are these enigmatic celestial objects genuine, or could they be the result of data transmission inaccuracies from Voyager 1 to NASA? Another intriguing possibility emerges. Could these objects be the handiwork of extraterrestrial beings? We will certainly enter into that zone. But before that, here is a small thing you can do for us. If you are new to the channel, don't forget to hit the subscribe button. Also press the bell icon right next to it and stay updated with such extraordinary videos. Back to the topic. The quest for understanding these celestial mysteries adds an extra layer of fascination to Voyager 1's ongoing mission. Neil deGrasse Tyson, a well-known figure in the scientific community, officially became part of this world when he enrolled at Harvard University to study physics. Beyond being an astrophysicist and author, Tyson is a passionate science communicator. He actively advocates for increasing NASA's funding, expressing concern that the current level of funding may hinder NASA's ability to effectively carry out its crucial work. In addition to his efforts to secure more resources for NASA, Neil deGrasse Tyson engages in discussions about the universe's prehistory, emphasizing that there is still much we don't know about the cosmos. He firmly believes in the importance of exploring these unknowns. Recently, Tyson's curiosity was sparked by the detection of 775 unidentified objects passing by in space, a discovery made by Voyager 1. While acknowledging Earth's remarkable features, Tyson highlights its relatively small significance compared to the vastness of the universe. This perspective, recognized by philosophers for centuries, gained validation when NASA scientists introduced a groundbreaking invention. This invention provided tangible evidence supporting the notion that, in the grand scheme of the cosmos, Earth is just a tiny speck. And the invention we're talking about might not exist if it weren't for the alignment of the stars, specifically the 4 largest planets in our solar system. This alignment went unnoticed until Gary Flandro, a PhD student at the California Institute of Technology and part-time worker at NASA's Jet Propulsion Laboratory, decided to chart the orbital paths of Jupiter, Saturn, Uranus, and Neptune. To everyone's surprise, Flandro discovered something extraordinary. In the late 1970s and early 1980s, these 4 planets would align like pearls on a celestial necklace in a long arc with Earth. This revelation thrilled Flandro's superiors at NASA because he was given the task of figuring out the most efficient way to send a space probe to explore Jupiter and the other giant planets. The alignment of these celestial bodies became a crucial factor in planning space missions, highlighting the fascinating connection between the seemingly distant stars and our technological achievements in space exploration. And this phenomenon indicated that a spacecraft traversing through space could potentially gain momentum through the gravitational forces of the massive planets it encountered. It's akin to the spacecraft being gently pulled by an unseen force, similar to an invisible cord that snaps at the final moment, propelling the probe further on its journey. According to meticulous calculations conducted by Flandro and his team, the cumulative gravitational assists from these planets could substantially reduce the travel time from Earth to Neptune, from an anticipated 30 years to a mere 12 years. However, Amid the excitement sparked by this groundbreaking revelation, a significant drawback came to light. The celestial alignment required for such gravity assists only occurred once in every 176 years. Consequently, for a spacecraft to take advantage of this unique event and reach its destination faster, it needed to be launched during the mid-1970s when the alignment was in effect. This temporal limitation added a layer of complexity to the prospects of utilizing this gravitational boost for expedited space travel. In 1977, NASA received crucial information that sparked a remarkable became an integral part of the Voyager space program. This program aimed at exploring both the solar system and interstellar space, providing valuable insights for our benefit. Over the course of nearly 5 decades, Voyager 1 has played a crucial role in this mission. Its communication with the scientific community is facilitated through the NASA Deep Space Network, where it receives routine commands and transmits valuable data back to Earth. And due to NASA and its Jet Propulsion Laboratory, they are privileged to monitor real-time distance and velocity data, contributing significantly to our understanding of the cosmos. In August 2023, the space probe Voyager 1 found itself positioned an astounding 24 billion kilometers away from Earth, earning it the distinction of being the farthest human-made object from our planet. The Jet Propulsion Laboratory took charge of both designing and constructing Voyager 1. This remarkable probe embarked on its journey from Launch Complex 41 at the Cape Canaveral Air Force Station, hitching a ride on a Titan IIIe launch vehicle. A mere 2 weeks after its companion, Voyager 2, ventured into space, Voyager 1 set off on its own unique trajectory. NASA initiated this mission with the ambitious goal of delving into the exploration of the outer planets, heliosphere, and interstellar medium. The space agency was driven by a profound curiosity to understand the mysteries that unfolded amidst the stars. The Voyager mission was envisioned to transform this aspiration into reality. In the early stages of planning, NASA scientists had already determined that Voyager 1 would undertake a flyby mission, visiting Jupiter, Saturn, and Saturn's largest moon, Titan. This decision marked a pivotal step in unraveling the secrets lying beyond our immediate celestial neighborhood. Despite being launched after its twin, Voyager 1 reached Jupiter before Voyager 2, where it conducted a comprehensive exploration of the gas giant, delving into the study of its weather patterns, magnetic fields, and rings. This mission yielded detailed images of the moons of both Jupiter and Saturn. However, the Voyager craft's mission didn't conclude with the study of these two planets. Instead, it extended its journey to investigate the outer heliosphere, exploring its regions and boundaries. Going beyond the heliosphere, Voyager 1 continued its operation, delving into the exploration of the interstellar medium. A groundbreaking moment occurred on August 25, 2012, when Voyager 1 crossed the heliopause, marking its entry into interstellar space. This historic achievement made Voyager 1 the first spacecraft to reach such a milestone. Subsequently, the confirmation of Voyager 1's presence in interstellar space was received 2 years later. The unfolding of events in the vast expanse of the universe revealed that Voyager had indeed embarked on a remarkable journey through interstellar realms. In the year 2014, the spacecraft encountered a series of powerful waves of coronal mass ejections emanating from the Sun, akin to tsunamis. This phenomenon persisted until December 15th of the same year. The spacecraft responsible for this remarkable journey was Voyager 1, which gifted humanity with its inaugural family portrait of the entire solar system, as observed from an external vantage point. Notably, it captured a famous image of Earth, affectionately dubbed the pale blue dot. Following its departure from the heliosphere, Voyager 1 embarked on a direct course toward the vast expanse of interstellar space, marking a pivotal moment in space exploration. Despite the initial mission timeline anticipating its conclusion many years ago, the spacecraft defied expectations, thanks to NASA's ingenious engineering team. Their efforts miraculously extended Voyager 1's mission to the year 2025. During this prolonged mission phase, concerns arose about the diminishing electric power available to operate the spacecraft's scientific instruments. The engineering team, however, demonstrated their prowess by conducting tests on the space probe's Trajectory Correction Maneuver, TCM, thrusters. This maneuver aimed to ensure the continued functionality of the spacecraft, enabling it to carry out scientific studies beyond the original mission duration. In the latter part of 2017, a significant event unfolded for the Voyager 1 spacecraft. After a prolonged hiatus since 1980, the decision was made to activate its thrusters. This strategic move proved to be a success, breathing an additional 2 to 3 years of life into the mission. Reflecting on the remarkable achievements of Voyager 1 over the past 4 decades, it's astonishing to think that its launch almost faltered in the summer of 1977. The setback occurred when a component of the launch vehicle unexpectedly shut down, resulting in 1,200 pounds of unburned propellant. Nevertheless, Voyager 1 is currently cruising at a speed of approximately 523 million kilometers per year, equivalent to covering 1 light year in 18,000 years. Delving into the intricacies of Voyager 1's journey, it becomes apparent that its remarkable speed would be meaningless without the right set of instruments. The spacecraft is equipped with 16 hydrazine thrusters, 3-axis stabilization gyroscopes, and referencing instruments. These instruments play a crucial role in maintaining the spacecraft's orientation, ensuring that its radio antenna remains pointed toward Earth. This collaborative effort is seamlessly integrated into the Attitude and Articulation Control Subsystem, AACS, showcasing the sophisticated technology that enables Voyager 1 to continue its extraordinary voyage through the cosmos. When Voyager 1 finds itself unable to establish direct communication with Earth, it relies on a crucial component known as its digital tape recorder, DTR. This specialized device has the capacity to record approximately 67 megabytes of data, which can be transmitted at a later time. As of the year 2023, signals transmitted from Voyager 1 take more than 22 hours to reach our home planet. The primary purpose of Voyager 1 extends beyond mere communication. It is equipped with advanced cameras designed to capture images of planets, moons, and other celestial bodies from considerable distances. However, the operation of these cameras, specifically those capturing visible light, is not a fully automated process. Instead, it is meticulously controlled by an imaging parameter table embedded in one of the onboard digital computers. Interestingly, NASA has moved past this operational model. Modern space probes developed since the 1990s come equipped with fully autonomous cameras. Despite this progress, Voyager 1 relies on a computer command system, CCS, to oversee its cameras. The CCS contains fixed computer programs, including command decoding, fault detection routines, and antenna pointing routines. This intricate system ensures precise and controlled functioning, allowing Voyager 1 to persist in its mission with a high level of efficiency. Voyager 1, positioned a staggering 14.1 billion miles away from Earth, might seem destined for failure, given its vast distance. However, contrary to this assumption, the spacecraft's computer systems have defied expectations, diligently functioning and transmitting valuable data back to NASA scientists. The credit for this remarkable longevity goes to the skilled engineers at NASA, who have played a pivotal role in ensuring the success of Voyager 1's interstellar mission objectives. The key to the sustained operational capabilities of Voyager 1 lies in the expertise of NASA scientists who have implemented effective power management strategies and integrated redundant computer subsystems. By judiciously turning off non-essential systems, they have conserved the spacecraft's power, contributing significantly to its enduring mission. The emphasis here extends beyond mere longevity. It encompasses the critical aspect of processing scientific data successfully. The meticulous efforts of NASA's engineers and scientists become evident as they grapple with the challenge of adapting Voyager 1 to changing conditions over the years. Beyond merely preserving the spacecraft, their focus extends to ensuring its ability to process scientific data seamlessly. This strategic approach has been crucial in preventing the loss of this prized spacecraft and has allowed Voyager 1 to remain self-powered through the utilization of radioisotope thermoelectric generators, RTGs. In essence, the extraordinary journey of Voyager 1 is not just a testament to its physical endurance, but also to the ingenuity of the dedicated individuals behind its continued success in the vastness of interstellar space. The radioisotope thermoelectric generators, RTGs, also referred to as radioisotope power systems, represent a specific category of nuclear batteries utilizing a device called a thermocouple. These generators employ the heat produced from the decay of plutonium to generate electricity through the Seebeck effect, known as the conversion of applied bias current, CABEC effect. Unlike traditional power sources, RTGs lack moving parts, eliminating the risk of wear and malfunction. Furthermore, they don't rely on solar energy, rendering them suitable for deployment in remote and harsh environments, such as the outer hemisphere, for extended durations. Despite the evident advantages of the radioisotope power system, there is a drawback associated with the continual decay process. Over time, these generators progressively produce less power annually. Voyager 1, for example, has experienced a diminishing power supply. Remarkably, this reduction in power has not adversely impacted the spacecraft's mission output. However, in a proactive measure, NASA engineers decided to address the potential loss by strategically turning off certain non-essential systems, including heaters, which do not influence the spacecraft's flight capabilities. This precautionary step ensures that Voyager 1 can continue its mission effectively despite the gradual decline in power production from the RTGs. It appears that not only are non-essential systems at risk of being deactivated to ensure the spacecraft's continued operation and efficient data transmission, but scientists are also contemplating the shutdown of a specific instrument on the spacecraft. Although a decision has not been definitively reached for Voyager 1, indications suggest that, like Voyager 2, it might experience the closure of one of its 5 scientific instruments. The rationale behind the delayed attention to Voyager 1 lies in the fact that one of its instruments malfunctioned early in its mission. However, the verdict on whether to deactivate a Voyager 1 instrument may become imperative in the coming months. Yet, it's worth noting that this decision might ultimately be deemed unnecessary, as scientists are actively exploring alternatives to avoid shutting down any instrument on Voyager 2. The AACS is a device on the spaceship that measures, reports, and adjusts the vehicle's position in space. It has an antenna pointing towards Earth to send data. Recently, scientists discovered that the AACS was sending data through a corrupted onboard computer. NASA engineers fixed this, and now Voyager 1 is sending correct data again. The big question is why the AACS switched to the broken computer. NASA suspects a faulty command from another computer, but they're not sure which one or what the problem is. They plan to examine the AACS thoroughly to figure it out. Despite this issue, NASA's Jet Propulsion Laboratory confirms that the AACS seems to be working fine, and no safety measures have been triggered. One possible reason for the problem is the tough space environment with extreme temperatures, cosmic radiation, and particles from space debris. These factors can interfere with the spacecraft's electronic systems, causing errors and data corruption. Although some suggest extraterrestrial activities as a cause, it's essential to consider various possibilities for the computer malfunction on Voyager 1. The captivating idea is increasingly capturing the attention of the scientific community. Many individuals are exploring the potential validity of this concept as an explanation for peculiar events. The hypothesis revolves around the belief in the existence of an extraterrestrial civilization that surpasses us in technological advancements. According to this notion, these aliens possess a superior understanding of space exploration, and it suggests that our Voyager spacecraft might have ventured to their celestial neighborhood. The possibility is considered that Voyager might have delved into deeper realms beyond the usual trajectories of conventional spacecraft. This could potentially clarify why we haven't encountered these extraterrestrial beings so far. Their location might be situated at distances beyond our current capability to detect their existence. The idea proposes that these advanced aliens could be residing in regions too distant for our detection methods to reach, offering a plausible explanation for their elusive nature in our observations. If Voyager happened to enter the territory of extraterrestrial beings, it's only natural for these outer space creatures to attempt to take control of the spacecraft. This could potentially explain the unusual behavior observed in Voyager. However, proving such an event is challenging due to our current technological limitations in exploring vast distances in interstellar space. Detecting creatures that have likely remained hidden for millennia poses a significant challenge. The hope lies in technological advancements that could give rise to spacecraft capable of not only covering greater distances, but also identifying extraterrestrial territories, assuming they exist. Looking ahead, we anticipate progress in technology that may help unravel the mystery surrounding the 775 objects discovered by Voyager 1. It's a waiting game, and as NASA scientists delve into this puzzle, we keep our fingers crossed for answers in the near future. Thanks for tuning in today. Keep an eye out for our upcoming videos. Stay connected and make sure to hit that subscribe button and the bell icon so you never miss an update. Until next time, take care.